Alright, how's everybody doing? So questions. Well, let's start with the latest ODP, and this is your last ODP for the week, the one you just turned in. So we're done with that for now. So this was our calculator program that function that takes a string, parses it, evaluates an expression, and then returns that expression as the function value. So a few things to keep in mind here. I suggested parsing with scanf using %d, %c, %d. Alright, so first thing, when you have %c, that goes along with a single character. Okay, you can't really properly do a %c and scan that into a string. So %d goes to an int, %c goes to a char. %s goes to a string, which is a character pointer. Alright, because a string is already an address in memory, when you scan with a %s, you just put the name of that string there. But when you scan with a %d or a %c, you need to put the ampersand in front of the variable name to say pass the address of that variable. Alright, so just like an integer, %c, the matching variable, has to have an ampersand in front. And then since you have a character, if you want to compare it to see if it's equal to a plus sign, you want to use single quote plus. So if you have character operator, you can say if op equals single quote plus. If we had a string, right, we would use double quotes, but there you'd want to use string compare. So if string compare string, comma, double quote something is equal to 0, that means the two strings are equal. So no strings anywhere in sight in this assignment except for the incoming argument, which we're just going to use as the first argument to scanf. And then we're going to pick up an integer, character, integer, and then proceed according to this description. If it doesn't parse like this, return a -1. If it parses but the operator is not one of these 4 characters, return a -2. Otherwise, do the calculation and return the value. And to do the calculation, just write a series of if statements based on the value of that operator, and either return the sum, product, difference, or quotient of the two numbers. So here's one version of that. Buffers my input string, calcs the function, it returns an int. I have two integers that I'm going to use for scanning into. I'm going to have an op, which is a character that I'm going to use to save the operator. And then here's my call to scanf. Right? So there's the string saying how I want to interpret the input, this buffer string. I want it to be an integer followed by a character followed by an int. And if this first integer is found, I want to save it in this variable n1, so I pass the address. If that's followed by any character, I want to save that in this character op, so I pass the address. And if that's followed by another integer, I want to save the value of that in the integer n2, and I pass the address. I'm asking scanf to do 3 conversions, right? I'm asking it to write the value of an integer, a character, and an integer. That's 3 things I want it to convert. So if it succeeds in doing all three of those, this function will return the value 3. If instead it only does the first two, it'll return 2. If it only does the first integer, it'll return 1. If it doesn't do any of these, it'll return 0. If my string didn't have any characters in it at all, it'll return -1. So how do I know that it found an integer character integer? Check to see if scanf returned a 3. Alright, if it did not return a 3, then there was a problem trying to parse my input. That's your -1 return. It says malformed expression or whatever. Alright, if stat did return a 3, I'm not going to do this return, so I'm going to come down here and execute my switch statement. So switch is functionally just like a bunch of if statements. This basically says if op is equal to this character, do this stuff. If op is equal to this character, do that stuff. If op is not equal to any of these characters, do the default stuff. So what does my switch statement do? If the character was a plus, I'll take my two numbers, add them, and return that. If it was a minus, I'll take the difference and return that. Same for the product and the quotient. And if it wasn't any of those four symbols up here, then I'll flow down to my default case and I'll just return -2, saying unknown operation. And it's worth pointing out here that normally when you see a switch statement, so you switch on a variable, and this has to be something that that would work with a double equal sign. So an integer, a character, something small like that. So switch on some variable, and then you can say case, value 1 colon, and list a bunch of statements. Case value 2. You're not required to have a default, but you can. And then an end bracket. So that whole thing is your switch statement. Okay, the way switches work normally, suppose that your variable matches value 1. It will do this statement, it will do this statement, and then it will go on and do this, and this, and this, and this, and this, and all the other statements in that switch block. If my variable matched value 2, it will skip this, because that's only applying if you match value 1. But once it matches value 2, it'll do this, and this, and this, and then all the other statements in your switch block. So normally, what you see at the end of all of these statements is a break. And a break statement says, jump down outside the block I'm currently in. So if you're in a for loop or a while loop, break takes you outside the loop. If you're in a switch statement, it will jump down outside of the switch. Let's see, question, does it do all the statements including the default? Yeah, so if I don't have a break, it'll do all of these, and it should also execute the default. As far as I know. I've never tried. Alright, in this case I didn't have to say break. Why? Because I'm doing a return statement. And if I return out of my function right here, I'm not in the function anymore. I'm not going to go ahead and execute all of these statements. Let's try this. All right. So test code, because I really don't know if this will work or not. So let's switch on I, which I'm setting equal to 2. So this should print out 2 and then 3 and then default. Let's see if that works. Yeah, I needed colons. I just changed those. Oh, that was weird. Yeah, no quotes. Thank you. All right, so yeah, once it matches, it flows through and does every other statement that you find. Here's a question: does default have to be the last thing? So that was kind of interesting. So I said switch on I put my default in the middle of my switch statement, and that did not fire. It matched the 2 and then it matched the 3 and printed those out. So what do you think it'll do if I set I equal to 5? Will it pick up the default? Or will it only pick that up if the default is the last statement? So that's kind of funky, right? If I is equal to 2, it seems to look ahead and find that it's going to match case 2, and then it matched case 2 and fell through to case 3, and it did not do the default. But if I was not any of these cases, it kind of looked ahead and said, oh, I have to do the default statement. It did the default, and then it fell through and did 2 and 3. I've never, okay, I don't think I've ever used a switch statement where I didn't have breaks at the end. It always feels kind of sneaky to me to do that. But you can do it. Just be careful if you do, because switch seems kind of sneaky sometimes. All right, but these are little exercises you can do when you want to know what's going to happen in some particular case. It's way more fun to do this than to try and look it up on Stack Overflow and get caught in flame wars and all that stuff. Write some code. It's good practice on VI. It's good practice on compiling, and it gives you a little puzzle to look at and solve, and that's always fun. All right. So any lingering questions on ODP 415? All right, so I posted an announcement this morning about group work and homework 7, and some people have already responded to this, but as of this morning, I'd only heard from a handful of people about working in groups for homework 7, so your deadline for letting me know about group work is tomorrow at noon, okay? So if you want to work in a group, one of two things should happen. Either send me email to my regular Clark, send me email on the Linux server, okay, if you're working in a group with other people. Tell me the names, full names, first name, last name of everybody in your group. And only one person in the group has to do that, okay? So send that on the Linux server. If you want to work in a group but you don't have anybody to work with and you want me to try to set you up with a group, send me email on my regular email account, so clark.edu, and tell me you're looking for a group to work in. But you've also got to tell me in there an email address and tell me it's okay to share that email address with other people. Okay? And tomorrow after noon, I will go ahead and try to take all those people and put them into groups of at least 2 people each. And then I'll send an email to everybody in each group with the email address of everybody else in the group. And then it'll be up to you to get in touch with one another and figure out how to coordinate and so on. All right. And if neither of those things happens by tomorrow at noon, then you're just working alone, which is a fine option also. But it's more fun to work in groups sometimes. And if you already wrote me and told me that you wanted to be put in a group, you still need to write me again at my clark.edu address. Give me your email address and tell me it's okay to share that with people, because I won't send people's email addresses to other people without explicit permission. So, so that's the story on group work. And if you send me your email address and tell me you want to work in a group today, I will send out that note today so that you can start working on this as soon as possible. So far, I only heard from 3 people wanting to work in a group, so I'll put those 3 together as soon as I get email addresses and permissions. All right. Questions on dialogue? Is that working okay for people so far? So I mentioned in the previous section I had some time last night, so I made a bash program to pull down voting results for Pennsylvania, just to kind of like eyeball, and I did one for Georgia that pulls down tallies, and then I did a general one that lets me just put in any state name and pull down the current tally from there. Not that I recommend staring at election returns all day or all night, but sometimes you can't resist, you know. Sorry?
Do South Carolina next.
South Carolina. There we go.
I'm curious how you would have to type it in since there's space between.
I guessed last night and I got it right first try. So this is a few commands that we're going to talk about over the next few days. One of them is curl. Curl is a nice way to just go out and grab a web page, right? Curl basically takes a URL and it returns whatever, you know, the browser, whatever the server sends back in response to that request. So you say curl URL and you get back, you know, all of this stuff. So if I just curl this, all right, I get back all of this information. And this is basically, you know, what my browser would get and interpret to display, you know, the nice web pages that we're used to seeing. And there's a lot of stuff in here, but and on it goes. But you can scrape that, right? And so my scraper is basically, I look for the tag last_name. I find the first occurrence of that, and then I split up my file so that every time I find last_name, that begins a new record. And then I search for the first one of those, and then I search for this pattern, which basically says votes : and each time I find one of those, I throw it on a separate line, and it leaves me a line with vote tallies separated by spaces, and I go ahead and I split those into new lines. So what are we using here? We're using a very small number of tools, and this plus one more tool is a pretty rich set of utilities for manipulating information in a Unix environment. So curl is a nice way to grab information from a web page. grep is a search program. It lets us search standard in for a particular pattern. In this case, I'm looking for the pattern last_name. sed is a stream editor. It lets us do replacements. It lets us say, find this pattern of characters and replace it with that pattern of characters. And that's all that I'm doing in here, right? But it takes all of this, right, all this stuff that came back from curl, and it turns it into, you know, a nice, easily interpreted collection of data. Right, I have a weather info. Linux, for some reason, the widgets that you get with a Linux distro for pulling down weather, they seem to break eventually. I don't know why. I had one that was, just displaying weather in the top of my window, and it just like broke. And so I wrote my own, and I threw in air quality because it was back during all of the fires, and I can just say weather info, and it shows me, what the current air quality is for different characteristics, and then just my temperature, barometer, and wind speed. And this displays in the top of my toolbar on my other window as a widget. And this is just more of the same, right? So I use curl to a government weather site, and then eventually to an environment flash site. And then there's some stream edits and some searches. And that's pretty much all you need. And awk, so awk is the last piece, which I want to start talking about today. But it turns, all of that information that comes from a website into, whatever format we want. So this is a really useful collection of utilities. Curl, which I don't have a whole lot to say about, grep, sed, and awk. And so if you're scraping web pages, curl is a nice way to go out and grab a web page. But for whatever it is you're trying to do, grep and sed and awk, really good, powerful set of utilities. So I want to start digging into what we can do with these things. So grep, sed, and awk. All right. So all of these things, so we won't worry about curl for now, but play around with it. It's fun. And don't underestimate the value of RSS feeds, right? RSS feeds were popular decades ago, but they're still around, and it's a really nice way if you want to sort of do some kind of automated collection of data from the web. Look for an RSS feed. These are things that just kind of serve up information in a usually pretty easy to process format. But let's talk about grep, sed, and awk. So let me give you a few examples first of all, and then we'll start drilling down into this. So let me hop into a test area. So I have a sample grades file here from our ODP assessment. The names have been changed to protect the innocent. But basically, when you do an assessment, when you say G, a record gets written to the bottom of this file, and it contains the ODP number, the username, a timestamp, the number of points you got, and the maximum number of points possible for this assignment. And this just keeps getting written every time that you do something. So Linda, for example, got a 0 out of 10, but then reassessed a little while later and got 10 out of 10. So this is the raw file that's built by the assess command. And once the ODPs are closed, I have to take this and use it to calculate and upload your grades. And this is automated. I have a big pair of bash scripts that do this for me. So what can we do with grep and sed and awk? One thing we can do with grep is we can look for patterns in a file. So for example, I could say search for the pattern Nick inside grades.txt, and there's all the records associated with the name Nick. And grep like this is just, it's just looking for this pattern of characters. So if there was a Nick appearing over here or over here, right, it would pick that up also. Or if there was an ODP named Nick, it would pick that up, right? But that's a basic search, okay? And if you don't find that name in there, you just don't get anything on your output. And grep also sets $? To show you the result of the search. If you get back a non-zero, it means it did not find what you were looking for. Whereas if you look for Nick and then you look at the return status, it's a good 0. That means success. It found the pattern. And grep, searches standard in. So if I don't specify a file name, right, it will match any input line that contains that pattern, hello in this case, and it'll print that out. So if I do a ps-elf and I search for Java, that will show me everything that came out of ps-elf that has the word Java in it. Right, so I'm on my home machine. Okay, cool. So yeah, so these are all the processes running that mention Java anywhere inside them, right? Including the command I just run, which was searching for the keyword Java. All right, so grep is a useful way to search for a pattern in a file or in standard in, which could be coming from a file, coming from the keyboard, or coming from another command. All right, so grep basically looks like grep pattern and an optional file. I can also, inside VI, I can search for patterns. I can say /Nick and brings me to Nick. If I hit N, it'll bring me to the next occurrence, and so on and so forth. All right, the cool thing about these patterns is there a set amount of characters it grabs around the query. So grep does line by line. So by default, it will show you the entire line if the pattern you're searching for is found anywhere on that line. You can add modifiers to say, show me a certain number of lines before or after also. So this pattern doesn't have to just be a set of characters. It can be what's called a regular expression. Usually just called a regex. And a regular expression is basically something that can include wildcards and all kinds of other things to specify a pattern. And we'll spend a good while just going through learning regular expressions. But for example, here's a regular expression. Let's search for a colon followed by any 4 characters followed by a colon. So a dot is the same as a wildcard. It says match any character. Could be a letter, a number, a space, could be a dot, could be anything. So I'm looking for, instead of NICK, I'm looking for a colon followed by any 4 characters followed by a colon. And if I do that, the first thing it finds is :Nick. And if I say N to search for the next occurrence of that pattern, it finds :data:. And if I search again, it finds :John:. And regular expressions are a whole world unto themselves. And like I say, we'll spend some time digging into them, but my usual disclaimer about most things Linux, right? If this is the world of regular expressions, this is what we're going to talk about. Okay, I'm going to give you probably, 7 to 10 things about regular expressions, and that's it. But I'll give you a rich enough set of things that if you put them together in the right way, you can do all sorts of searching for patterns. And so one of these is a period, which is a wild card, right? So we'll play with those more later, but let's stick with a higher level overview. So we can search for a pattern with grep. And we can also do this inside VI by just saying / and typing in a pattern. But, grep will also understand regular expressions. So there I just pulled out all of the 4-letter names by using this pattern. Now, if there was something else that was 4 characters separated by colons, it would also have identified that. Right, even if it wasn't a name, because I didn't tell it anything in particular about, looking in the name column. It's just looking for 4 characters separated by colons. And, one of those characters could be a colon, and that would still match our pattern. All right, so that's a little bit about grep. If we go back to VI, we can also do edits using regular expressions. So for example, suppose I want to change the name Nick to Rick. I could say colon, substitute Nick with Rick. All right, this is a general structure. Colon, S means substitute, and then in between slashes I list the thing I'm looking for, which is Nick, and then in between slashes I list the thing I want to replace it with, which is Rick. And if I do that, right, my name Nick just changed to Rick. Or let me make it more profound. Let's substitute Nick with shouting Nick, right? And we can specify that we want to do this on more than just the current line. And if I want to represent all the lines in the file, I can say 1, $. $. Means the last line. So every line in the file, let's substitute Nick with shouting Nick. And it tells me it made 5 such substitutions. So one of them is right here. There's another one, there's another 2, and there's 1, and then there's the first line. So if I go inside VI, I can do this colon command to substitute on one particular line, or I can say colon first line, comma last line, where those are numbers, substitute old with new. And in particular, I could do $sign for the last line of the file, so 1, $, substitute old new replaces something everywhere in the file. Well, we can do that in VI. We can also do it outside of VI, and this is basically what sed can do for us. So sed is short for the stream editor. VI is a visual editor where we say VI file, and we can see, a piece of the file and move around it and edit by looking at it. A stream editor we give commands to, and it edits the file without our interacting with it. We basically say, here's the changes I want you to make in the file, and it will go ahead and make those changes. It's a very different way to edit. But if we use the stream editor, we can do something like this. Sed, substitute Nick with Nick. And I can give it the name of the file. And it will apply that substitution on every line where it's possible to apply. And it hasn't changed my file, grades.txt. It reads from standard in, or it reads from a file, and it takes the results and puts that into standard out. But if I wanted to save this to a file, I could redirect standard out to new grades. And now if I look at new grades, it's got those edits in it. Or if I just wanted to see the lines that got changed, I could take this whole sed command and I could pipe that into grep and look for uppercase Nick, and I would just see those 5 new lines that I edited in my file. And I could redirect that into Nick grades, and now I've got, a file just containing those selected grades. All right. So sed stream editor lets us make edits to a file as we process it from beginning to end. All right. The other piece of this that I want to mention is awk. And we'll spend a few days talking about awk next week or the week after. But sed basically edits files line by line. Awk lets us process files field by field. So we take a file and we think of it as being a set of fields separated by some delimiters, and we want to do things with particular fields in there. That's when we go to awk. Okay, so let's take a look at our grades.txt file. And in this case, our fields are separated by a colon. Okay, awk normally separates things by spaces. So let me show you a simple example of awk first. So awk, quote, curly bracket, print $3, comma, $1, close bracket, quote. Okay, this is asking awk to read input from standard in, break it up into a set of fields separated by spaces, and on each line that it reads, print out the third field followed by the first field. All right, so it's reading standard in. So I'll say this is a test, and it prints out this. All right, that's the third field. That's the first field. If I say what's going on, it prints out on and what's, third field and first field. If I only have one field, it'll just print out that first field, and $3 was missing, so it just printed a space for that. And when I get to the end of my input, I can hit Control D to signal end of file. All right. And awk has one really important switch, which is -F, and we can specify a different delimiter besides a space. So if I want to separate my input with a colon, like that, right, it'll print out is fun, or is hello. If I do testing 1, 2, 3, that's all one field because there's no colons in there. So that just prints out as the value of $1, $3 was missing. All right, so let's print out $2, comma $1. Let's run that on the grades.txt file. $2 should be the user's name, $1 should be the ODP number. I've got a list of usernames and ODPs. So if I want to see all the ODPs that have been done by Houdini, right, I can take the output of that and I can search for Houdini, and I can see Houdini tried 3 times on ODP 450 and didn't do any other ODPs. And I can also print out field 6 followed by a slash followed by field 7. Oh. Right, and I can see their grade on each of the ODPs. So they got 0 out of 10 twice, and then they got 10 out of 10 on the third attempt. All right, so grep lets us search for patterns, sed lets us edit lines of text, awk lets us break up lines of text into fields. Okay, that's a really, really high level, fragment of a sentence synopsis of each of those utilities. They're all much richer than that. But from a first order, that's a useful way to think of these 3 tools. And let me just show you some of the the things we can do with that. Let's see. So your ODPs come in with, you know, a grade file like this sitting on the server. I pull that down and run a couple of commands on it. So process grades basically takes that file and pulls out the last entry for each ODP username pair, right? And prints out the username, the ODP, and then the score that the user got on that, right? 100 times the number of points they got divided by the maximum number of points. And this creates a file of assignments, users, and scores. And then there's another script I run, which will take that and turn it into a file, a CSV file, suitable for uploading to Canvas. Right, and so it's really just changing around the format of it. So a lot of calls to awk. And this is actually a more complex awk program. And we'll talk about that next week. But it's mostly, right, just printing out information from that grades file in the right format to give me a CSV file that I can upload to Canvas. And so these are Unix commands. They can be run inside scripts, right? You can do quick, you know, one-offs just by typing commands at the command line, but usually we put them inside a script, and we might do things like the following. So suppose we want to know the last score that, I'll pick on myself, the last score that Nick got for ODP 452, right? So I would grep ODP 452 from grades. And I would pipe that through a search for Nick. Well, let me do 450. Let me make it harder. All right. And I want the last grade, so I'm going to pipe that into tail-1, and that'll give me the last record. Okay, well, I want to manipulate that, so I'm going to save that in a variable called record. And so I'm going to run the whole grep command, the tail command, inside back quotes, and set record equal to the result of that. Okay, this is like what you do in your dialog command that you're going to write, you know, into your script for homework 7. So you run these things, but instead of displaying them on standard out, we save them into bash variables, because now I can take this and manipulate it however I want. So I might do something like right, if I do this and I type in this line, got to specify the file separator to be a colon, right? It will print out field 6, which was, you know, my score. But instead, I want to do this awk command on this variable record, right? So I can do the following. I can say echo the value of this field, this variable record, and pipe that into awk. With the file separator, right? So that will pull out this 6th field, which is the number of points that this person was awarded on an assignment. If I do $7, it'll show me, you know, the total number of points possible. So let me make it a little more interesting. right? So let's say that I only got 10 out of 30. So if I okay, so let's say that's the record I pulled out. If I run that through my awk command and I print out field 6, I get my 10. If I print out field 7, I get my value 30. And if I want to manipulate those further, I can do something like this. Points equals back quote, and put this whole thing inside back quotes. And if I want to know the maximum points, I can set max points equal to that. And now points is equal to 10, and max points is equal to 30. And now if I want to know the score that this person got, I can just do some arithmetic. So I can do 100 times points, divide by max points, do it inside $paren, and there's the person's score. All right, so the storyline here is, right, this is not magic. This is a small set of commands that you learn how to use and you figure out how to put together to do things. All right, and basically awk lets you break things into fields, sed lets you make changes to a line, grep lets you search for patterns. And those three, we'll use them a lot over the next week to do these kinds of things. All right, so so tomorrow's class will be short. I have a meeting at 11:30, so it's only going to be a 30-minute class tomorrow, and I'll refer you to the lecture video from the section A at 10 o'clock for whatever we don't get into. Can you have multiple file separators for awk? I think you can. I think you can specify more than one. Give it a try. Just put a couple of characters after the -f, and I think that works. All right, cool. Have a good one. Talk to you later. Thanks.